we have to execute the unification algorithm that you can see on your screen. We have to apply this algorithm to pairs of atoms. In the exercise, we can see 3 pairs of atoms. So first, we should apply the unification algorithm to those 2 pairs, to these 2 atoms. You know what is the purpose here? We try to make those 2 atoms the same, character by character. This is the purpose of unification. And the purpose of this algorithm to find a unifier. A unifier is a set of necessary substitutions which make the 2 atoms being unified the same. Okay, so let's start to run the algorithm. In step 1, we have to check if the 2 atoms start with the same predicates, and actually, yes, they do. They both start with the predicate P. Therefore, we don't have to halt here in step 1. We can keep going. In step 2, we introduce a notation sigma to the unifier we are about to generate. At the beginning, this unifier is empty, but during running the algorithm, we will extend this unifier step by step with new substitutions. At the very end of the algorithm, if we successfully found a unifier, the unifier will be in this sigma set of substitutions. Anyway, we will see how to do that. In step 3, we have to check if there are different characters in the 2 atoms, and yes, we can find 2, A and Z. They are different. In step 4a, we have to check if any of those 2 basically terms is a variable. This is important. One of them must be a variable. I forgot to tell you that A is a constant in this exercise. X, Y, Z, and U are variables. Therefore, in this case, yes, Z is a variable, A is a constant, so we can keep going. Actually, in the algorithm, the 2 terms are denoted by T1 and T2. So now T2 is a variable, and this is very important to know. In step B, step B is just about notations. It's not an important step. However, step C is very important. It is called the occur check. Basically, now we have to check if the variable Z appears in the other term A as a parameter, and it does not. So Z does not appear inside A, and this is good because we can keep going to step D. In step D, we are extending the unifier sigma with a new substitution. Basically, we have to substitute the variable with the other term. So in this case, we have to substitute Z with A. This is a new substitution we have just added to the unifier. In step E, we have to apply this new substitution to both atoms here. Okay, let's do this. So basically, we have to substitute A into every occurrence of Z. Z has 2 occurrences, so we substitute both occurrences with A. Actually, this means that the first 2 terms become the same. And actually, this is as I already mentioned, this is the purpose of the unification algorithm, to make all the terms the same inside those 2 atoms. Okay, in step F, we go back to step 3. So again, in a loop, we check if there are any different characters in the 2 atoms. Yes, there are. X and FA. They are 2 different terms. And of course, we have to check in step B if any of those two atoms is a variable. Yes, X is a variable, very good. Then we execute the occur check. We check if X appears in f of A. It does not, so we can keep going. And in step D, we add a new substitution to the unifier. X is substituted with f of A. In step E, we have to apply this new substitution to both atoms. In this case, it means that we simply substitute this occurrence of X with FA in the first atom. So those two terms become the same. Okay, go back to step 3. We check if there are any different characters left in the two atoms. Well, actually, the next two characters are the same. We can find the function f in both atoms, but we have to continue, and then we find G and U, which are different. In fact, we have those two atoms have two different terms. In the first atom, we can find G of Y. In the second atom, we can find U. Okay, as I already explained, U is a variable. We check if U appears inside G of Y. It does not, so occur check was successful. And then we have one more duty. We have to add another substitution to sigma. We have to substitute U with G of Y. And of course, we also have to apply this substitution to the atoms. And at this point, we can notice that the two atoms became the same. So in step 3, we notice this fact, and we stop. Only in this case, only in step 3, the algorithm can result with success, and you can find the output of the algorithm inside sigma. So this is what we were looking for: a unifier, a set of necessary substitutions which make the two atoms the same. Okay, so we are done with the first part of the exercise. Let's continue with the second pair of atoms. So as you can expect, the two atoms start with the same predicate symbols R. Then we find two different characters, X and Y. Actually, both are variables, so we can keep going, definitely. Occur check is only important when one of the terms is not a variable. In this case, both terms are variables, so we don't have to run occur check this time. And then let's add a new substitution to the unifier, the substitution of either Y into X, or since both of them are variables, we can substitute X into Y as well. It's up to you which one you choose. I'm choosing substituting Y into X this time. Therefore, those two terms become the same, and we can keep going. Actually, you have to substitute Y into every occurrence of X. Therefore, in the next step, in the next loop, in the next iteration, we have to unify Y against f of Y. And this is interesting. As at the beginning, everything seems okay, but when executing the occur check, we hit an obstacle because the variable, this variable occurs inside the other term, and this is prohibited. This is what the occur check checks, actually. So if this is the case, then the algorithm must halt with with a sad face, so it was unsuccessful. We couldn't find any unifier. There is no way to make those two atoms the same. So there is no unifier in this case, unfortunately. Okay, now let's check out the third pair of atoms. And of course, the two atoms start with the same predicate Q. Then we find two different terms, f of a and y. Y is a variable, therefore we extend the unifier with a substitution of f of a into y, and therefore those two y's must be substituted with f of a. And then let's keep going. In the next step, we find two different terms, g of x and f of a. And now we have a serious problem, because we found out in step 4a that the two different terms, g of x and f of a, are not variables. None of them is a variable. They start with two different functions, and those two functions cannot be the same, whatever you do. Therefore, we have to stop with a sad face. So there is no unifier. There is no way you can make those two atoms the same. You cannot unify those two atoms either.